All right, we're live. We're live.
Just go home.
Okay, here's our first job. Number one, do we know what a quadratic is? Do we know what a quadratic is? Let's start off the lesson by giving you a f of x equals 2x. What do we think about that? Is that quadratic? If we even know what quadratic is. So this is a linear function. We just went over that. Okay, so no, it's not quadratic. Okay, I'll give you another example. So no, not a quadratic. How about f of x equals 2x squared? Yes. This is a quadratic. Okay, so anything with a degree of 2. X needs to be 2. So it's pretty simple at this point. I'm not going to try to elongate that part. If x has a degree of 2, it's a quadratic function. Actually, the parent quadratic function is f of x.
Wait, the second one is yes?
Yes, so this one is, yes, it is a quadratic. Okay, so now to tell you what a quadratic is, the parent function, so parent, I'm going to put this here, parent quadratic function, and I'm going to give that to you. Quadratic function. Actually, can you guys guess? So I told you that a quadratic is anything where x is to the second power, that's a quadratic. Okay, if you find an x to the second power, you have found a quadratic function. What do you think the parent quadratic function is going to be? Meaning no changes to it, no numbers, just the most basic you can get it. Lucia. Equals 1, not quite. It needs to be quadratic. Remember, it needs to have an x with a squared in it somewhere. Yes, Lisa?
f of x equals x squared.
X equals x squared. Here's your parent function. Okay? What does that look like, you might ask? I will tell you.
Wait, that's a quadratic function?
This is a quadratic function, and also it happens to be the parent quadratic function. Meaning, it's just the most basic quadratic function I can possibly give you. Alright, what does it look like? So now we are in the realm. We're still on the coordinate grid. Okay, so we haven't left this, so we're still in some area that we're familiar with. And it just looks like this. It's a curve, it looks like a U, and it has arrows this way and this way. Okay? So, and it kind of points outward. It doesn't just go straight up, it goes up at an angle. Okay? And it goes right through the origin 0, 0. Okay? So this is your parent quadratic function here. Here's what your parent quadratic function looks like over here. Okay? So that's the name of the game. This is the realm that we are in for the next couple of weeks. A curved line. Okay? We're used to having something like, something like that. As a slope of whatever, as a y-intercept of 2, it's a straight line. But now we're in the realm of curved lines being able to be done on a coordinate grid. And how do you do that? By taking x and raising it to the second power. Okay, so far so good. Okay. So, can we identify a quadratic function now? Yes or no? Yes. Okay. All right, so the next part of the lesson is, actually I was going to say something, but I totally forgot what I was going to say. We're going to analyze quadratics visually, and we're going to say some things about them. We're actually going to get better and better at quadratics to the point where we'll even be able to graph one. Eventually, you will see something like f of x equals x squared minus negative x squared minus 5. Eventually you will see this and you'll know exactly how to graph it. You don't know how to do that yet.
Is that a parent function?
This is not a parent function anymore. This is a quadratic, yes, but it's not a parent function. Good question. All right, but you eventually will know how to graph that, okay? So let's break down quadratic. I'm going to give it to you in small, bite-sized pieces. Okay, first question is, let's just go to this parent quadratic function. There's a term called the axis of symmetry. Okay, that's the first big term you need to make sure. Axis of symmetry. Okay, so the axis of symmetry is the line that cuts the parabola. Oh, sorry, I should have told you that what this is. This shape here is called the parabola. Okay, parabola. Parabola, if you're trying to think about how to spell it. It's parabola. Okay? So the very first thing we're going to do is find the axis of symmetry, the line that cuts it in half perfectly. And actually, we're going to give that line an equation. So can somebody perhaps that doesn't care to be in the video want to come up and draw where they think, with this pink marker, where they think the axis of symmetry will be? The thing that cuts it in half perfectly into two equal pieces. Because it is symmetric. Can we agree that it's symmetric? Yeah. So can somebody come draw the axis of symmetry? Essel, you want to come up? Okay. You don't care being in the video, right? Awesome. All right. Just draw a dashed line
What's an
where you
axis
think
of
it'll be.
symmetry?
Yeah, on this.
No idea.
Axis of symmetry is the line that cuts the graph perfectly down the middle.
Wait, what? Can you repeat that?
Axis of symmetry? Yeah, it's the line that just, well, I mean, I'm not giving the textbook that, thank you. That is perfect, by the way.
Thank you.
It's the line that cuts it perfectly down the middle, so that if you fold both halves, it lines up on top of each other. Okay? So axis of symmetry, and when I ask you in the future, can you give me the axis of symmetry, you're going to give it to me in equation format. Now, thank goodness, not long ago, I told you how to give me equations of horizontal and vertical lines. Can anyone tell me what the equation of that axis of symmetry is? Patrick.
X equals 0.
X equals 0 is correct. Yeah. So I'm going to ask you in a test. Here's a quadratic. It's in the shape of a parabola, of course, because that's what quadratics always will be shaped as. Tell me what the axis of symmetry is. You're going to give me an equation, x equals something. For this one, x equals 0. Okay? Let's try another example. Okay? I'll put it over here. Okay? And this time, and excuse that for, it doesn't really matter for the sake of this. Can somebody give me an axis of symmetry for this one? Just what you assume it'll be. I know it's not going to be exact. I don't even have these numbers labeled here. But if you had to give me an equation that seems feasible based off this drawing for an axis of symmetry, what would you tell me?
Like x equals 4.
X equals 4, I'm cool with that. X equals 4, yeah. So we'll just say that's a value of 4 here. X equals 4. Okay, that's how you find the axis of symmetry. Do we understand this sufficiently for me to move on to the next topic? So, number 1, can we identify a quadratic? Yes, we can. Anything with x squared. Can we find the axis of symmetry? Seems like yes. Do we have any questions on it though? If you don't, tell me now. Because I'm going to move on to something that's not really much more complex than this. We good? Okay. So, parabolas, quadratic functions, also have another term. So I'll put a bubble around all the key terms that you need to keep track of. Axis of symmetry is one. The other one is called the vertex, which maybe you remember when we talked about absolute value function, is the vertex. What is the vertex? What is the vertex? It's just the very tippy top or the very tippy bottom of the parabola. Okay? So let's get a different colored marker here. Can somebody come up to these two parabolas on the board and draw me where they think the vertex is? The very tippy top or the very tippy bottom? So come on. Here you go. So just put a dot where you think the vertex might be for both of these examples. Yeah, the bottom of the hill and the top of the hill. Fantastic. Beautifully done. Okay? So here's the vertex for this parabola. Here's the vertex for that parabola. Okay.
The what?
The vertex. The vertex of the parabola.
Is that little dot?
It's the dot right here. Yeah, it's either the minimum here or the maximum here. Okay, so maybe I'll actually put this, here the vertex is a maximum, so I'm going to actually put that. Here, vertex, actually I don't know if I'm in frame or not, so I'll put it down here. Vertex is a maximum. I remember what I was going to talk about before. Yeah. So here your vertex is a maximum, and here there is no minimum value. There's only a maximum, because it goes down for infinity there. All right. Here the vertex is a minimum value. Vertex is a minimum. Vertex is a minimum value. It doesn't have a maximum value. It goes up for infinity, but we know it has a minimum value, and that's the vertex. All right, so what I was going to discuss before, okay, so do we understand vertex? We will eventually find a way how to, we'll be able
Wait,
to.
so that little dot is the vertex?
Yes, yeah, and we'll be able to find that eventually. Okay. I want to go back to the topic of domain and range for a second. For the parent quadratic function, let's use this one for the example, okay? What is the domain and range? Do we remember? We need to keep practicing that because as we introduce more different topics here, we're going to want to keep the topic of domain and range. Do we know the domain and range?
Yeah.
What is the domain for that top one over there, which is represented by this equation? What is the domain of that function?
0.
What is it?
0.
No, not 0.
X.
No, not x. Remember the domain? You guys remember the topic of domain? So I'm just going to keep the parent function f of x equals x squared. And I just draw it over here. All right, pretend it goes through 0, 0, because it does. All right, the domain here is, shall I say it?
Yeah.
All real numbers. I'm going to put it in this notation, negative infinity, comma, infinity. All right, that's going to be that's my preferred notation, so I'm going to use that. Okay, x is greater than negative infinity, less than infinity. That's another way we could write it. What's the range? So I told you it goes through 0. That's definitely a point on this graph. What's the range? I don't think we remember, so I'm going to tell you. It goes from 0 on the lowest end to the highest end, it goes to infinity. So it goes from 0 to infinity. So your domain is all real numbers, because as far as left and right is concerned, it goes forever. But range, it has a minimum value here. It has a minimum. It's a concrete number, it's 0, and then goes up for infinity. Okay? All right. So, the next activity is more independent work. I'm going to ask you to make me a table of values for a quadratic function to be able to graph it. Okay? So, let me erase, well, actually, let's keep that for a second. Here's your example. Okay? It's going to be f of x equals x squared plus 1. Okay? All right. You're going to make me a table of values. I'll give you the x's. I'm not going to always do this, but I'll give you the x's, and you're going to tell me, and then at that point you could give me your f of x's or your y values, and you can graph it. I'm going to ask that you use -2, -1, 0, 1, and 2. All right. Do you know what I'm asking you to do here? Take the x values, plug them into the equation, find out what the y values are, and then plot it on a graph. And it should have a U shape. You know you're trying to develop a U, a curved U. Okay, so I'm going to pause for a second to give you guys time to work on it. All right, class, just say it out loud. F of -2. 5. F of -1.
2.
2. F of 0.
1.
1. F of 1.
2.
2. F of 2.
5.
Nice. Beautifully symmetrical. Beautifully symmetrical. Okay. Which means if I'm plotting this, I have 0, 1. -1 and 1 are both at 2, so 2 up here, 2 up here. And then 2 and -2 are at 5, so -2, 5, and 2, 5. So look at that nice little U we got there, guys. That's very nice. Okay, parabola, quadratics. That's what's happening here. Okay. I'm shifting over to the next part of the lesson. You guys have long blocks, so it's kind of, actually, do I split this up? Yeah, I'm gonna split this up.